Good afternoon, bacho. How have you been? I hope you all are doing absolutely fine. So we met yesterday, and I promise that once again I will be meeting today. And today we are going to be initiating a very important topic of basic mathematics, and that's true that this is going to be used everywhere, even in chemistry, in physics. Definitely the application part is going to be there, and in maths it's because it's a part of mathematics in the end. So hello, good afternoon. Once again, if I'm audible to you, you can give me a thumbs up. And after that, we are going to be initiating this session. So welcome to day 5. That's 16th of April 2025. So we are about to start with integration. That's the name of the topic. I will teach you how to integrate because I have seen that students find integration to be very interesting, and I believe that you all will be also finding this to be interesting. So let's get started. So integration, from the name itself you are able to find out something is being summed up, isn't it? Something is being summed up. In other words, I can say that it's being summing up of elements. So you can start writing it down. Summing up of elements, everyone. So I will take a very basic example. In the previous sessions, in the case of differentiation, I have already mentioned that it was an elementary section was being taken. Anything was being broken apart, but integration we are going to be summing it up. So let's try to see what's happening over here. So I am taking a rod, everyone. We are taking a rod. The rod is having some length, L, let's say. The rod is having a length of L. So now if I start cutting the rod, if it's a metallic rod, I will be using a metal cutter. So if I keep on starting to cut the rod, then what's going to be happening? Let's say I'm trying to bifurcate it into pieces. Small elements we can get, isn't it? What we are trying to do, this green symbol denotes cutting off. Cutting up of this rod. So we are going to be getting certain elementary sections, isn't it? So I can say that each and every elements are going to be delta L1, delta L2 and so on. So now we are going to be making this more simpler. I am just trying to cut a very small element from the rod. Let's say it's going to be, I am trying to cut this delta L. So if I remove this delta L, what's going to be the length? What is going to be the length over here? So I can obtain the length of the rod becomes, after cutting, it's going to be, anyone? You can mention that thing in the chat box. What do you think is going to be the length of the rod after cutting a very infinitesimal element, which is delta L? So it is going to be L minus of delta L, isn't it? And as a result of that, I hope it's clear, it's going to be L minus of delta L. Delta L is going to be, what is delta L over here? That's an elementary section or infinitesimal element. I have already used this term while teaching you differentiation, if you can recall. Over here, it's going to be the same itself. So now what I am going to do is, we can cut n number of delta L's, isn't it? Until unless nothing will be there. But now I am trying to teach you integration. What is it? So now this delta L part, let's say, is situated somewhere over here. So now what needs to be done? It's a metal, and I want to attach this delta L back to this L minus of delta L. So what I am going to do? I have to use certain technique like welding. Isn't it, everyone? I believe that you people might have heard the name welding. So if I am going to be welding this, then what I will be getting? Let's say I am trying to attach this section. So we are attaching this section once again by the means of, so as a result of that, what is going to be the total length? The total length is going to be L minus of delta L plus delta L, isn't it? Delta L gets cancelled out, and as a result of that, I will be getting the original length. Isn't it, everyone? And I will be getting the original length back, isn't it? Yes or no, everyone? If yes, if you have understood this, give me a thumbs up. So this is what is known as integration. This is what is known as integration. Summing up of elements. So now let's try to find out what does it mean. So integral symbol is going to be represented by a special type of symbol denoting a snake. Whenever you are able to see snake symbols, it's going to be giving you integration. That means you are just trying to find out some integral. You are being asked to find out the integral of any function. Once again, you need a variable for the integration, isn't it? So now, if nothing is being mentioned on the top of the snake or the bottom of the snake, we are going to be calling these integrals to be indefinite integrals. And now, if I am going to be having some limits associated, means let's imagine that the snake. Okay, I believe that everyone might have watched Harry Potter, isn't it? Everyone might have watched Harry Potter. If yes, give me a thumbs up. Right? If you might have watched Harry Potter, everyone? Okay, fine. So everyone knows about Slytherin, isn't it? If you might have heard about Harry Potter, there is a house known as Slytherin, and Slytherin's symbol is going to be that of a snake. It's like this. So now if I am going to be having some limits, let's say A to B. So whenever you are able to find out that the snake is wearing a crown and it's something there over there at the bottom of it, so I will be calling these as definite integrals. So once again, you need to integrate the variable with respect to an elementary change of that function. For example, if I am having any function, so let's try to understand what is it all about. So now comes the theory portion. It's going to be a bit boring, but try to understand, because this will be helping you out in order to solve some questions in the upcoming context of this session. So if I say that let fx be a function. If you can recall the same function, I'm using it over here. What was the function? We are talking about y is equal to fx. So if I'm going to differentiate this function, what I will be getting? I will be getting over there as dy by dx, isn't it? Is nothing but f dash x. I believe everyone's clear with this part. Everyone knows this. Dy by dx is going to be represented as f dash x. If yes, give me a thumbs up. Give me a thumbs up, everyone, if it's clear to you. We have already discussed this thing in the previous sessions, in the previous 4 sessions, if you can recall. So now, if I'm going to be integrating this, let's try to take this function. And what I'm trying to do, we are trying to integrate this once again. If I'm going to be integrating this derivative with respect to dx, trust me, my friends, I will be getting the original function fx itself. We are going to be getting the original function fx itself. So henceforth, what is integration? I can say that integration is the reverse of differentiation. Integration is going to be the reverse of differentiation. In other words, I can say that integration is also known as antiderivative. Integration is also known as, so I will write it down with some different color for the betterment of yours. So I will write it down over there, that integration is the antiderivative of, that's it. So I will give you certain examples. It's an antiderivative, okay everyone? Integrations are antiderivatives from the term itself. I already mentioned in the very first lecture session of mine, I said that integration is going to be reverse the opposite of differentiation. And so today we are coming over here in order to discuss this, isn't it? So what needs to be done over here in this context? So now let's try to know some identities associated with integration. Once again, I would like to show you that integration is nothing but antiderivative of differentiation. Okay? So now everyone knows that d by dx of sine x is equivalent to cos x, if you can recall. Raise your hands, those who already know this. D by dx of sine of x is cosine of x. Everyone knows trigonometric functions, isn't it? Okay? Or else I will give you even simplest function as comparative to this. I can say that d by dx of, let's say, x square is going to be equivalent to 2 times of x. Let's try to take these two functions. Now what I will be going to doing is, I am going to be integrating these functions, the derivatives with respect to dx, because x is the variable over here, isn't it? So what I will be doing, it's going to be, let's try to do it with the first example. I can say that if I integrate cosine of x with respect to dx, I can say, I can write it down that it is going to be equivalent to sine of x plus some constant c. So you just need to know that there is going to be a constant term coming after the positive symbol, the plus sign, the sum sign, whatever I will be writing it down. But in the case of definite integrals, this constant term will vanish. So that's why whenever you are writing down any terms related to integration, you need to write it down it as the value with a plus c, where c stands for some constant over here. Any constant it can be. Why we are writing down this constant? Because in the upcoming days, once you join Sri Chaitanya, and now if you are going to be solving any problem of kinematics or laws of motion, which is based upon variables, let's say questions related to variable acceleration, over there you need to find out a differential equation and then you need to put certain initial conditions. During that case, this constant term is going to be beneficial. Okay? So now if I am going to say, once again I will be trying to do this integration, let's say integration of 2x dx. So it has to be, once again I will be mentioning with the formula. So actually integration of 2x dx, 2 is going to be coming outside, it's going to be x dx. It's said to be that integration of x dx is x square by 2. Don't worry, hold on your hats. I will be mentioning you with the formula. So I can write it down it as 2x square by 2. As a result of that, I will be getting it as x square. The same function we are getting it. So henceforth proven that this statement which I have given to you henceforth is proven, that integration is the anti-derivative of differentiation. I hope it's clear to everyone. If yes, give me a thumbs up. We are going to be knowing the identities now, and after that we are going to be moving towards problem solving session. Okay, shall we proceed? Okay, so fine. So let's start with the basic formulas associated. The basic formulas have to be very, very important. So you can write down the formulas which you need to do, which you need to know in order to solve integration. Now we are dealing with indefinite integration. We are now dealing with indefinite integration. Okay, so what we are going to do is, so what I will be saying is, yes Venkateshwara, don't worry, with the problem I will be mentioning you once again. Okay, so what I am about to say is, indefinite integrals we are going to be dealing with. That means those snake symbols which are not having any term associated at the top or on the bottom, isn't it? So now let's try to understand this. So first of all, this is the symbol. What is this, everyone? This is the symbolic representation for indefinite integrals. So the first rule, let's try to write it down. The first rule is being stated as integration of sine of x dx. Okay, we'll start with the polynomial function, because if you can recall I mentioned the derivative of polynomial function. So I will be saying that integration of x to the power n dx. What is it, everyone? x to the power n dx. X is any polynomial of any arbitrary degree. Let's say the degree is n. It can be anything, n0, 1, 2, 3, 4, anything. Not 0, it's going to be 1. Anyways, over there itself as well, it's going to be used. So now this is going to be equivalent to x to the power n plus 1 by n plus 1 plus c. This is going to be integral of x to the power n dx. Now the next trigonometric function, that is integration of sine of x dx. So that is going to be equivalent to minus of cosine of x plus c. Third one, which I have already discussed over here, which is integral of cosine of x. So it has to be sine of x itself, isn't it? So integration of cosine of x dx is going to be equivalent to sine of x plus c. Number fourth is going to be integration of secant square x dx is going to be equal to tan of x plus c. Number fifth, all the derivatives, whatever derivatives we know, if I integrate it with respect to dx, I will be getting these functions itself, everyone. So number fifth is going to be integration of sec x tan of x dx. Over here the variable is x, isn't it? So that's why we will be able to integrate only with respect to x, isn't it? So now we are going to be getting it as is going to be equivalent to what? You know that d by dx of secant of x is sec x tan x, isn't it? So I will be getting it as secant of x plus c. So like this, you can also try to find it out for exponential and logarithmic functions, isn't it? We already discussed about this. Integration of dx by x. This is a very important integral. This is a very, very important integral. It's going to be used in most of the topics of physics. So that's why pay attention, everyone. Most of the topics of physics, whatever you all are going to be knowing in the upcoming days. Okay. So now what I will be saying is integration of dx by x is going to be equivalent to ln of x plus c. What is ln of x? I have already mentioned it in the previous classes, isn't it? Where I was teaching differentiation. This ln of x means log of x base of e, isn't it? Now last but not the least, the seventh one which you need to know, that is going to be integration of e to the power x dx. So that is going to be e to the power x plus c, because you know that d by dx of e to the power x is e to the power x itself, isn't it? So these are the formulas associated over here. The next upcoming context will be problem solving. So let's try to understand the problem solving part right now, isn't it? Okay, everyone. So those who did not understand with the problems, I believe that it will be clear to you. So try to focus over here. Try to focus over here. Don't get deviated. You can chat with me, not with your friends. Okay? If you want to ask anything, ask it from me. I hope you got it. So now what I am about to say over here is, okay, so now comes over here the first function. I will write down this function over here, the one which I mentioned. You can note down the formula. This is the function which we have to do. Let's say it's being given as integrate with respect to, WRT is the short form of with respect to. I believe everyone knows with respect to x, and the function over here is being given as the first function. It should have been, this is 5 of x square plus 3x minus 2 dx, isn't it? This is the function, everyone, in front of us. So now what needs to be done? Lot of things are required to be done. We are learning integration, isn't it? We all are learning integration. And for that, what needs to be done? We need to use the formulas. The formulas which I already mentioned it over there, isn't it? So now what needs to be done in this case? If you know, you can solve the answer and mention the result over there in the chat box. If not, I will just try to mention. So first step, what needs to be done? First of all, this dx, just like if you can recall in differentiation, I was using that d by dx as an operator, isn't it? So this dx can be used as an operator. It can be incorporated in between the brackets and we can integrate it separately. All these functions could be integrated separately. So what I can do is 5x square dx. This is what I am trying to say. This is what I am trying to say, my friend. Okay. So 5x square dx plus integration of 3x dx minus of integral of 2 dx. This is what I am saying. This is what I am saying, everyone. So dx is being brought inside the brackets and I am multiplying it. In other words, it's being used as an operator and I am integrating it. I hope it's clear. I hope it's clear, everyone. So now as a result of that, I can say, now you say what needs to be done. 5 is a constant, 5 comes outside. Integral of x squared dx plus 3 integration of x dx. 2 is constant, it can be taken, constants can be brought outside the integral expression. Outside the snake symbol, you can bring it. And the same thing I used to do in the case of differentiation, if you can recall. So now what I will be getting, 2 integral of dx. Now tell me the answer. I've already mentioned with the formulas, isn't it? So over here, if you're able to see that all the 3 functions are polynomial, isn't it? Just like this one. All the 3 functions are polynomial functions, just like this. And we know that polynomial of any arbitrary degree can be integrated like this by using this equation. Integration of x to the power n dx is x to the power n plus 1 by n plus 1. So let's try to do this over here. So now this becomes, what do you think will be the answer? Write it down in the chat box. X to the power 2 plus 1 by 2 plus 1. That's it. This is how we need to do. 2 plus 1 by 2 plus 1, isn't it? Now plus 3. Now tell me what's going to be integral of x dx. Write it down over there in the chat box. What is integral of x dx? X dx I am saying. It's right. That's going to be x cubed by 3. So x dx is going to be equivalent to what, everyone? So that is going to be equivalent to x to the power 1 was there. X to the power 1 plus 1 by 1 plus 1. This formula, x to the power n plus 1 by n plus 1. Isn't it? Plus integration of integral of dx. See, over there I am having a minus sign, that's fine. So let's try to use it over there. Minus of 2 integral of dx. Always remember one thing, that integral of dx is going to be equivalent to x. Always remember one thing, that integral of dx is going to be x. Okay. So this is going to be x itself. Because nothing is there, right? 1 is there. So always remember one thing, that integration, I will write it down. Remember, those who are learning this for the first time, they can say that, remember, I will be saying, remember my words. Integral of dx means integration of 1 into dx, which is going to be equal to x. If it would have been integration of 1 into dt, then I would have obtained it to be as t. Okay. So as a result of that, I will be mentioning it over here as, let's try to write down the result. So it's going to be 5x cubed by 3. Over there it's going to be 3x square by 2 minus of 2x. Of course, don't forget this c, the constant. So this is going to be the answer. Understood? Understood? If yes, give me a thumbs up. Like this session. Don't forget to like this session. Okay? Yes? Those who did not understand, with the next problem we can try to understand. Okay? Keep on posting, everyone. Keep on posting. Okay, so let's move to the next question. I hope with the next question it will be clear to everyone. So next question is this. Next question is going to be this one, the one which I'm having it over here. That is integral of 4 of sin x minus of 2 by x dx. So what needs to be done over here in this situation? Those who already know, they can Write it down over here, isn't it? It's going to be, this dx can be brought inside. 4 sin x of dx minus of 2 by x dx. Okay? Clear? This is how we can do. Integration of 4 sin x dx minus integral of 2 by x dx, isn't it? Yes or no, everyone? So as a result of that, I can say that 4 can be taken outside the integral. 4 integration of sin x dx minus 2 can be taken outside the snake symbol, dx by x, isn't it? Yes. So as a result of that, what I will be getting? Integration of 4 integral of sin x dx. So it has to be, we have seen that integral of sin x dx over here, which is minus of cosine of x plus c. This is what needs to be used over here, isn't it? So now as a result of that, 4 of minus of 4 cosine of x minus of 2 ln x plus c. Once again I have mentioned this identity, isn't it? We are using these two formulas. Integral of sin x dx is equivalent to minus of cosine of x plus c, and similarly I am using integral of dx by x is ln of x plus c. So as a result of that, I will be getting it as this is going to be our answer to this question. Okay? So this was very easier. This was a lot easier than the previous question. Okay, everyone? Got it? Got it, everyone? This is the formula. It's going to be formula based itself. So we can try to solve. Ln x is log base e, Punit. Log x is, log can be have two bases. One is e, so that can be written as ln of x, and subsequently another base is there, which is 10. So obviously that's the reason we have to be specific. Okay, that's the reason I am writing it down it as ln. Always remember this. Which one you are talking about? Which last one you are saying? Once again I am saying 4 we can be taken outside the integral of sin x dx. 4 is constant, okay? Minus of 2 can be taken outside dx by x. So 4 integration of sin x will be, you know that integral of sin x is minus of cosine of x, and over there integral of dx by x is ln of x. That's what I am trying to say. Okay? C is a constant. C is a constant. You just need to write down that C, nothing else. You will be knowing the exact significance of C in differential equations. It's a part of your math syllabus. Along with that, you are going to be dealing with such situations from the chapter kinematics in the context of variable acceleration. Okay? So now let's try to move towards the next problem which we are having. It will be giving a better clarity what it's all about. Now this one, there comes the most difficult part, I will say. There comes, these are not easy, okay, but I will make you feel easy. These are not easy, but I will make you feel easy, trust me. So now what I am about to do is, this cannot be solved directly. We are not having any function, any direct formula for this function. For that, what needs to be done is, we need to, limit is not there right now, it's an indefinite integral. It is an indefinite integral, everyone. Okay? So what I am about to say over here is, integral of dx by 4x plus 5. So now, we have to do it by the means of integration by substitution. See, there are several ways by which you can do integration. In class 12, this is going to be taught in your mathematics JEE curriculum. Integration by substitution. There are several methods. I will write it down. Likh lijiye sab. One is going to be integration by substitution. Okay? I'll write down the lists which you can use it. There are several techniques. We are discussing about the techniques, everyone. Number 1 is integration by substitution. Number 2 is going to be integration by elimination. Number 3, integration by parts. Number 4 is integration by partial fraction. Okay? So these are the techniques of integration. But we are not going to be discussing the entire integration over here, because this is nothing but the basics. From the term itself, basics of mathematics, I already mentioned, you need to understand it first. So we all are going to be only understanding only one thing at this point of time, that is integration by substitution. So this problem can be solved by the means of integration by substitution. So what needs to be done, everyone? So first of all, let me try to define something. I need to define another variable. If you can recall the chain rule, I defined a third variable, isn't it? I defined a third variable, everyone, if you can recall, while teaching chain rule, the orthodox method. And then after that, I just try to sort it out, like with the means of a shortcut, isn't it? So now what I am going to do is, in this context, okay, so now what I will be doing, just pay attention. For the basic functions, it's possible, the one which you are saying about the antiderivative property about which I mentioned, okay. So now I will be choosing, let 4x plus 5 is equal to z. I am assigning another variable which is z. Okay. Now this function, if you are able to see, this function becomes what? This function is going to be written as this, like this, see, dx by z. Clear, everyone? This can be written as dx by z. But obviously integration is not possible. Integration is not possible because we need to integrate any function with respect to an elementary change of itself, isn't it? I have already mentioned this, isn't it? So that is the reason you need to convert this dx. This dx needs to be changed to d of z. And for that, what needs to be done? We need to form a differential, everyone. We need to form a differential. So what differential are we talking about? The differential is going to be d of 4x plus 5 is going to be equivalent to d of z. So now this d, what is this d? There comes, so you must be thinking, so what is this d? I knew that d is going to be an alphabet and that too small d, but over here in mathematics d is being used, isn't it? So it proves out to be different, isn't it proving out to be really different? Something is different, isn't it, everyone? So now what I am going to do is, I will be considering the d which is in the LHS. The d which is present in the LHS over here is nothing but d by dx into dx. And the d which is on the RHS is having a significance of d by dz into dz. So that's why we call this d as the differential form. You will be knowing this thing, learning this thing in thermodynamics. D of PV, pressure into volume, is PdV plus VdP. So over there, at that point of time when you are going to be taught thermodynamics, don't say to your respective sirs or madams, whomsoever are going to be teaching you thermodynamics, okay. So that's why focus here. D on the left can be written as d by dx, to the right is going to be d by dz. So now what needs to be done? So we can write this as d by dx of 4 of x plus 5 into dx, step by step, just try to understand. And over here I can write it down it as d by dz of z into dz. Okay, everyone? We can write it down like this because we don't have any tax to pay, isn't it? This dx can be brought over there because it's a multiplication sign. It's associated with the multiplication sign. Okay? So now as a result of that, what I will be doing is, I will be writing it down. See, pay attention everyone. So this d by, what is going to be d by dx of 4x plus 5? Everyone who knows differentiation, everyone who is aware about differentiation, they can write down the answer to this. What is d by dx of 4x plus 5? Write down the answer over there. Everyone. Four. Okay. Great. It has to be 4 itself, isn't it? It's going to be 4. Keep on writing down, everyone. Those who know the differentiation, it has to be 4. Okay, great. So now as a result of that, I can write it down it as 4. This becomes 4. This becomes 4. This entire term is going to be equivalent to 4. And what is going to be d by dz of z? Bata dijiye. What is d by dz of z? Write down the answer over there in the chat box. What is d by dz of z, everyone? D by dz of z. D by dz of z, I am asking. 1. Okay. Great going. Everyone has practiced differentiation, it seems. From R.D. Sharma or from the objective of Sri Chaitanya module. Okay, great. So now what I am going to do is, we need to write down it properly. So this becomes 1. Both sahi, sab 1 likh raha hai. Sahi hai. So we have to write it down it as 4 and dx will be left. 4 dx is equal to 1 into dz, isn't it? Can I write it down like this? 4 dx is equal to 1 into dz. If yes, give me a thumbs up. I can write it down, isn't it, like this? Okay? After differentiating, this is 4. 4 into dx is equal to d by dz of z is 1. So 1 into dz, isn't it? So now there comes a relation. Now our drawback, the drawback which we are having, that is, we were having dx. Obviously we could not have integrated z with dx, isn't it? So now as a result of that, we are able to find out the relation in between dx and dz. So now I can say, profoundly write it down as dx is dz by 4, isn't it? Let's say this was the first equation, this was the second equation. So if I am putting equation number 1 and 2, write it down. Putting 1 and 2 in the main equation. In the main equation, what I will be getting? We are going to be getting it as integral of dz by 4. Isn't it? dz by 4 into z. Okay, everyone? dz by, I am writing it down with a bigger font size. So I will be saying it as dz by 4 into z. Okay? dz by 4 into z. So this 1 by 4 can be taken outside the integral, isn't it? Nikal dijiye bahar. 1 by 4 integral of dz by z. What is integral of dz by z? Write down in the chat box. What is integral of dz by z? Write it down in the chat box, everyone. Integration of dz by z, right now itself I mentioned in the formula. Ln z, ln x plus c nahi, it the variable is z over here. So you need to write it down in the terms of z itself, isn't it? Yes. Keep on writing, everyone. Ln z. Everyone, those who are getting this, write down the statement. Write down the statement over there. Ln of z. Ln of z, exactly. So I will be getting it as 1 by 4 ln of z plus c. But now, is this the answer? Do you think that this is the answer? If yes, you can write it down over there. Do you really think that this is the answer? No or yes? No. Exactly, no. Nahi hoga na bhai. What is the variable over there? The variable is x. So we need to reconvert back. We need to reconvert back the original function. We cannot express our answer in terms of z. So what do you think will be the final answer? The final answer will come out to be 1 by 4. Instead of z, I will put it as 4x plus 5, isn't it? So it is going to be log mod of 4x plus 5. Why mod? Because ln or log, I will mention it in the upcoming days. Once we start graph, once I start graphical representation, and I think so in maths it's already being taught about graphs, isn't it? Log can only have positive values and it has to be greater than 0. Okay? So now what I will be doing over there is, it's going to be ln of mod 4x plus 5 plus c. This is going to be the answer to the question. Did you get it? Did you get this as the answer? If yes, do mention it over there. आंसर मिला आप लोगों को? Because it साई सात्विक it will be having only positive value. ln का सिर्फ पॉजिटिव वैल्यू आता है जो कि 0 से ऊपर रहता है. It should be greater than 0. Okay? It cannot even be equal to 0. That's why it's mod. Sai Satvik. It should be having only positive value. It should be having only positive value. We know that. I will write it down over there. Ln x has to be always greater than 0. In other words, I can say that this x has to be greater than 0. It cannot even be equal to 0. Okay? This x has to be greater than 0. Okay, so now it's fine. So now let's try to solve another question. I hope this one it's fine. Okay. Now how to do this? How can we do this? With this, I believe that it will be clear. Once again, we need to use integration by substitution. Can you people solve and give me the answer? Can you people solve and give me the answer? And those who are joining recently, they can go to the previous lecture sessions. Once you know differentiation, then only you can come across integration. Without knowing differentiation, doing integration will be a bit difficult. So that's why I insist, it's my request from the bottom of my heart to know differentiation. Okay? Okay, so what I'm saying is this is integration by substitution. So what I will be doing over there, it's let 6x plus 2 will be z. Okay, thumbs up. It's fine with this step. 6x plus 2 is equal to z. I can take 6x plus 2 is equal to z. Okay. Next, form differential. So as a result, this integration becomes what? Z cube dx. Possible to do? Is it possible to do? Yes or no? Write it on the chat box. Not a problem. Write it down over there in the chat box. Is it possible to write it down? Z cube dx, is it possible to find? Is it possible to integrate? Yes or no? It's not possible. Because over here you are able to see we are having d of x and this is z. Not possible. This integration is not possible. So as a result of that, you need to convert this dx. This dx needs to be converted to dz. Isn't it? So what I will do, I need to form differential. D of 6x plus 2 is d of z. isn't it? D of x plus 2 is d of z. So what I will be writing down, so d to the left is going to be having an expression of d by dx into dx of 6x plus 2, isn't it? And the d to the right is d by dz into dz in brackets z. Okay, everyone? I hope it's clear. This is how we can write down. The d to the left is having its own significance. The d to the right is having its own significance. Okay? So now what needs to be done? So can I write it down it as d by dx? Those who did not understand the previous question, they can see 6x plus 2 into dx is equal to what? D by dz of z, isn't it? We are having d by dz of into dz. Okay, now you tell me, what do you think will be these differentiation? What is going to be d by dx of 6x plus 2? Write it down in the chat box. D by dx of 6x plus 2, please do write it down in the chat box, everyone. 6, correct. Once again, a request, those who haven't understood this, please go through differentiation once. Watch the previous lecture sessions, trust me, you will be getting this thing for sure. Yes, 6 is going to be the value. Take dx is going to be equivalent to what is d by dz of z? What is d by dz of z? Please do write it down over there. What is d by dz of z, everyone? D by dz of z is 1, isn't it? So it is going to be 1 into dz. So now you are able to get an expression of dx in terms of dz. So dx is dz by 6. Put it over there in the integral. So now it can be easily integrated, right? Z cube of dz by 6. Yes or no? If yes, give a thumbs up. Give a thumbs up. Okay. Give me a moment. The session is not ending it yet. Okay, I'm about to end. So as a result, what do you think? 1 by 6 can be taken outside. Z cube dz. We are going to be having z cube dz, isn't it? So what do you think will be the value of it? What is integral of z cube dz? Write it down over there in the chat box. Write it down in the chat box, everyone. What is integral of z cube dz? So that is z to the power 4 by 4, correct? I already mentioned it, right? It's a polynomial once again. Integral of xn to the power n dx is x to the power n plus 1 by n plus 1. So I will be getting it as z to the power 4 by 4 into 6, isn't it? Plus c. So as a result, it's going to become z to the power 4, 24 plus c. Is this the answer? Do you really think that is the answer? Is it the answer? Yes or no? Is it the answer? Nope. It's not the answer. Because you need to reconvert back the variable into its original function. So what needs to be done? Z is this 6 of z, 6 of x plus 2. So the answer is going to be, this can be written as, so the integral's answer is 6x plus 2 to the power of 4, isn't it? It has to be 6x plus 2 to the power 4 by 24 plus c. Theek? Okay, everyone? So this has to be the answer to this question. Okay, fine. So tomorrow we are going to be bringing some more questions based upon it, and we are also going to be solving definite integrals as well. So that's it for today. Thank you. I hope you enjoyed the session. If yes, like it, comment over there, and don't forget to subscribe our Sri Chaitanya Educational Institution channel. Okay. practice integration from R.D. Sharma or from the objective of Sri Chaitanya module itself. I will be recommending these books. Try to practice the basic indefinite integral questions, because today we discussed about indefinite integral questions, okay? And objective. Tomorrow I will be back once again at 4 p.m. Indian Standard Time with definite integrals, 16 naught. Okay, so if you have any questions you can ask. Now the class is over. Those who want to interact, they want to ask about something, they can ask. The homework problem, Dhanyashri, you can post it over there. Which problem are you mentioning about? Differential model is not available. It should be there. In class 11th, book is there. Notes will be shared in Telegram, everyone. That link was already being shared. Yes, exactly. The PDFs which are coming through Telegram are your notes. So you should be following it. In Madhapur, Hyderabad, Sai Satvik. No, we cannot integrate 6z cube dx. We need to convert it. It's not possible. The variable should be same. What I'm trying to say is x can be only integrated or differentiated with x. Okay? Similarly, z with dz, t square with dt itself. Else it's not possible. Okay? What else? Yeah, hello. They should be posting the notes. My name is Avinav Banerjee. I have already mentioned it to you in the very first lecture session of mine itself. Once again, I would like to write down the name. This is what my name is. Okay, everyone? Anything else? First question, we could have added constant, Surya Tej. Constants are only used because you will be finding the essence. Till this point of time, you know indefinite integral, just write down plus c. Nothing else. Got it? Integration of ln x Sai Satvik can be done by integration of parts. That is going to be taught in maths curriculum. So, I told you, right, for physics teachers like us, we need to make you understand the basics in order to solve any complicated problem of physics in all the techniques, whatever we are going to be using in all the chapters. We just need to know the integration of substitution. It will be used. I can give you certain examples. One is trying to find out the gravitational field due to a ring, then trying to find out the electric field due to a uniformly charged ring. Then in Biot-Savart's law, in certain applications for finite wire current carrying conductor, we are going to be using integration. What else? Homework questions. You solve it on your own. Tomorrow we are going to be giving you homework questions once I complete definite integrals. Okay? Got it? Okay then? Thank you very much. Don't forget to like the lecture session. I need likes from you guys, isn't it? Integration of x sin x, once again it can be done by the means of integration by parts. If I get time, then I will definitely mention integration by parts. Okay, integration of ln x, integration of x sin x can be done by integration by parts. Okay, please do solve questions from either of the two books, objective questions from your Sri Chaitanya module if you are already enrolled with Sri Chaitanya itself. Fine then, thank you very much. Good night.